We are Team Strathclyde. We all study in the Naval Architecture and Marine Engineering Department at Strathclyde University, and this is our plan for a zero CO2 oil refinery.
The first question is, what is CO2? The Oxford English Dictionary defines it as a colourless, odourless gas. However, in general society, it is viewed in a much more negative way, as almost an evil greenhouse gas.
This public opinion is what led us to our idea of capturing CO2 from the refinery and selling it at a marked down price to greenhouse owners. This would be a clean and safe way of recycling CO2 into O2.
At the moment, the vast majority of greenhouses use hydrocarbon burning CO2 generators in order to implement their CO2 enrichment programs. These operate by using a burner to burn off short-strip hydrocarbons like methane, butane and propane to reduce the CO2 to enrich the greenhouse's environment. However, this does have a downside of producing a large amount of heat.
Our alternative is to utilise existing carbon capture technology in order to bottle CO2 and sell it for commercial and private use in greenhouses. We also found that we can quadruple the volume of CO2 in the air from 300 parts per million to 1,200 parts per million. This has the potential to increase plant growth by about 250%, therefore benefiting the greenhouse owners whilst also safely and cleanly disposing of CO2 in a useful manner.
There are many methods of carbon capture. The most common types are post- and pre-combustion capture. Pre-combustion consists of 3 stages. Hydrogen fuel is converted into hydrogen and carbon monoxide from a synthesis gas. Carbon monoxide is converted into CO2 by reacting it with water, which is known as a shift conversion. Then the CO2 is separated from the hydrogen, which can then be combusted cleanly. Pre-combustion can capture up to 95% of CO2 emissions, but has high NOx emissions. Post-combustion methods involve removing the dilute CO2 from flue gases after hydrocarbon combustion. The most common method is passing the CO2 through a solvent and absorbing it. Post-combustion equipment can retrofit to existing refineries but has a high running cost and limited experience on a large scale.
Based on this information, we decided that in this situation, post-combustion carbon capture methods are the better option, as it is possible to retrofit an existing refinery using these methods. It is an existing technology, and although there is limited experience on a large scale, it is the method favoured by the UK government. Pre-combustion methods do seem more effective, but the technology required is still in its infancy, so at present we do not see this method as being feasible.
Based on the existing plans for a CO2 pipeline between Falkirk and Aberdeen, we would like to place a bottling plant in the vicinity of the refinery with a short connecting pipeline between the 2 sites. From there, a fleet of lorries or trains, depending on the local infrastructure, can be used to distribute liquid CO2 to the various greenhouses across the country. The main way in which we plan to do this is through utilising supermarkets and gardening centres in order to reach the necessary markets.
We considered planting trees in order to offset some of the CO2 that was not possible to capture. However, upon researching this further, we discovered that the volume of CO2 consumed by trees in this manner is so low that it is not a feasible idea. It was found that 1 acre of pine trees could only absorb about 100 tonnes of CO2 over 90 years, which on average is about 1 tonne per acre per year, which with the amount of CO2 produced in a standard oil refinery is going to require an unrealistic number of trees in order to really offset this carbon. However, the increase in public image and opinion which can be gained from a project such as this could mean it would still be beneficial overall.
In conclusion, we would like to implement a post-combustion carbon capture scheme to collect the CO2, then using a variety of proven methods, bottle the CO2 in pressurised containers and distribute to greenhouse and agricultural projects across the country.